Hello. Hello, everyone. Amazing. So hopefully you've been working hard on the assignment. This topic is maths. We're doing coordinate geometry today. And let's get started. So I've got 9 questions prepared for you today. Various level of difficulty. So let's start. So coordinate geometry. So coordinate geometry is all about working in Cartesian coordinates, of course. So we have the x and y axis, and we call this the xy plane. And they are perpendicular, and that means that this is an orthogonal system, something you'll learn about at university. But anyways, find the equation of the lines that pass through these pairs of points. There are several ways you can do this. And sometimes it's just advisable to find anything special about them. Can somebody spot anything special about the first pair of points? It has the same y coordinates. Yes, of course, that means it's a horizontal line. So if you do 3, 7, minus 4, 7 is going to be here. So it's a horizontal line. And we know that a horizontal line has coordinates y equals 7. So that's it. You don't even need to solve anything. You don't need to find the gradient. You don't need anything. So a horizontal line has equation y equals 7. Easy. This one, similarly, has the same x coordinates. And if you draw these points, so this is 2, 6, and this is 2, 9. So that's a vertical line. Not only you don't need to find the gradient, you won't be able to find the gradient, because if you attempt to find the gradient, the formula for the gradient is y2 minus y1 divided by x2 minus x1. This is going to be 9 minus 6 over 2 minus 2. You have 3 over 0. That is undefined. Undefined. It's impossible to find the gradient. A vertical line does not have a gradient. Or we say it has an undefined gradient, or we say it has, what can we say? Well, oh, the horizontal line is y equals 7. That's the equation of the line. And that makes sense. Y is always 7. That's what it says here. Y is always 7. It is. For any point, y would be 7. For a vertical line, the equation of the line x equals 2. That's an equation of a vertical line. Equation. You could do this, the first question, using the classical one. So find the gradient first. The gradient is y2 minus y1 over x2 minus x1. So that would be 7 minus 7 over minus 4 minus 3, which would be 0 divided by minus 7, which is 0. So the gradient is 0. And then you take any point. So for example, this point. And then you use the formula y minus y1 is equal to m x minus x1. This is the formula to find the equation of a line if you know the gradient and a point. And here you can do y minus 7 equals 0 multiplied by x minus 3. So this is 0. So y minus 7 is 0. So y equals 7. That's the equation of the line. So same thing here. Right, so okay, moving on to the next one. So you have 2, 4 and 3, 8. So you could say, all right, so you have 2, 4 and you have 3, 8. And you have a straight line going through. And so the gradient is y2 minus y1 over x2 minus x1. That would be 8 minus 4. That's 4 over 1, which is 4. And then you say, okay, y minus y1 is equal to mx minus x1. That's the equation for a line with a given gradient going through a given point. So we choose, let's say we take this point. Take 2, 4. And that is y minus 4 equals 4x minus 2. Open the brackets. Y minus 4 equals 4x minus 8. Y equals 4x minus 4. And that's the equation of the line. Okay. This one, slightly more complicated, but it's straightforward. And so slope is y2 minus y1. Actually, you know what? I'll use a different formula for this one. If you have an equation of a line going through 2 points, like let's say x1, y1, and x2, y2, you can write down the equation using a single formula. Y minus y1 over y2 minus y1 equals x minus x1 over x2 minus x1. And all you need to do is to substitute the coordinates. So there's going to be y minus 1/7 divided by 3/7 minus 1/7 equals x minus, plus 3/4 and 1/4 minus, plus 3/4. And that looks horrible, but it actually isn't. I'm going to multiply the first fraction by 7. So I got 7y. Actually, I don't really need to do that, but okay, or whatever. Minus 1 divided by 3 minus 1, which is 3 minus 1. So I'm going to times top and bottom by 7. And here it's going to be x plus 3/4 divided by 1. And this is 2. So 7y minus 1 by 2 equals x plus 3 over 4. Times the whole thing by 2. You get 7y minus 1 equals 2x plus 3 over 2. 7y equals 2x plus 1 plus 3 over 2, that's 5 over 2. Divide the whole thing by 7, you get y equals 2/7 x plus 5/14. That's it. That's the equation. So hopefully that makes sense. Coordinate geometry. We're talking about straight lines. So the assignment is due in 2 weeks on the 15th of December. Just under 2 weeks. Okay, problem 2. Find the equation of a line that passes through a given point and crosses the y-axis at 60 degrees. Ooh, that's interesting. So let's make a sketch first. X and Y. So 2, 7, that's here. 2, 7. And it crosses the y-axis at an angle of 60 degrees. What can we do here? Well, first of all, we need to understand how angle to the axes is related to gradient. Because effectively, we want to know the gradient and we want to know the y-intercept. So how is the angle is related to the gradient? Who's read the assignment carefully? Who can tell me? Okay, Amo, it's yeah, it would be 1/10. If you have a line, the angle here, so tan of that angle is equal to the gradient of the line. Yes, Ben, thank you. Yeah, so tan of this angle is the gradient. Therefore, we need this angle, but this angle is 60. That means this angle is 60. This is a right angle triangle, so this angle is 30. So in this case, the gradient is equal to tan 30 degrees, which is square root of 3/3. That's something you should know, but if you don't, you can look it up. Okay. And then we have a point. So we use the point slope formula, which is y minus y1 equals mx minus x1. And that is y minus 7 equals root 3/3, x minus 2. And then you just open the brackets. So y equal, so root 3/3x minus 2 root 3/3 plus 7. And that's the answer. You don't need to do anything about it, anything else. You won't be able to simplify it any further. That's it. Does that make sense? Does problem 2 make sense? If I give you problem 2 right now and ask you to do it, would you be able to do it? Having seen how I did do it. On a scale of 0 to 10, please. So 10, yes, without any hesitation, and 0, no idea how to do it. Okay, good. Moving on. Okay. Show that a straight line with equation is parallel to the straight line with equation that. Well, we know that if lines are parallel, they have the same gradient. So let's write down L1 and yeah, A. L1 has y equals 2x plus 4. So the gradient is 2 because that's the number here. L2 is 6x minus 3y minus 9 equals 0. And then make y the subject, so 3y equals 6x minus 9. Divide everything by 3. Y is equal to 2x minus 3. and the gradient is 2. They have the same gradient. That means L1 is parallel to L2. Hence, L1 is parallel to L2. B. Find the equation of the straight line L3 that is perpendicular to L1 and passes through the point. So we have L1, we have L2, and we have a third line which is perpendicular to L1. If it's perpendicular to L1, it's also perpendicular to L2. It's not given, but that's implied. It passes through point 310. So there's a point 310 somewhere here. And this line passes through that point. Well, what can we figure out? We need, as you could remember, to find an equation of a line, we need a point and a slope. Because there's only one line with a given slope that goes through a given line, a given point. So if you have a point, you can only draw exactly one line going through that point with a given gradient. So if you know the gradient, if you know a single point on the line, you know the line. The gradient of the perpendicular is the negative reciprocal, correct? So if the gradient of these lines is 2, the gradient is 2. The gradient of this line, M3, is the negative reciprocal, so it's minus 1/2. Yeah, so line L3 has gradient minus 1/2. And it goes through this point, so we use the point slope equation. So y minus y1 equals m x minus x1. Y minus 10 equals minus 1/2 x minus 3. Y minus 10 equals minus 1/2 x plus 3 over 2. Y equals minus 1/2 x plus 23 over 2. I'm just simplifying. I'm just combining 10 plus 3 over 2. That's 23 over 2. Yeah. That's the equation. Find the point of intersection of lines L2 and L3. So where does L2 meet L3? This is line L3. L2 meets L3. To find the intersection of two lines, you need simultaneous equations. Use simultaneous equations. And then y equals minus 1/2 x plus 23 over 2. That's L3. And L2 is 6x minus 3y minus 9 equals 0. That's L2. So this is a set of simultaneous equations. I use brackets. You don't have to use brackets, but this makes more sense to me, at least. And then you just sub that in. Let's divide the equation by 3. Because 2x minus y minus 9 minus 3 equals 0. And then you sub this in. So so 2x plus 1/2 x minus 23 over 2 minus 3 equals 0. Times by 2, just not to bother with the fractions. So it's a 4x plus x minus 23 minus 6 equals 0. 5x equals 23 plus 6, that's 29. X is 29 over 5. And then y is, use any equation, so minus a half times 29 over 5 plus 23 over 2. That doesn't look pretty, but times by 5. That's going to be minus 29 over 10 plus 115 over 10. 115 minus 29. That's 86 over 10. That's 8.6. Okay, so y is 8.6. And x, let's make it a fraction as well. So it's 5.8. Is it? Yeah. Yeah, 5.8. Okay, so that's the intersection. So the intersection of the points is 5.8, comma 8.6. Find the shortest distance between the lines L1 and L2. L1 and L2, the shortest distance, or just the distance between the lines. So you have two parallel lines. The distance between two parallel lines is the length of the perpendicular. But this bit is perpendicular to both. So let's call this A, and this is B. C, D. Shortest distance is the length of the perpendicular AB. So we found point B. We need to find point B. And point B is the intersection. So to find point B, we solve simultaneous equations. Y equals 2x plus 4, and y equals minus a half x plus 23 over 2. We make them equal to each other. 2x plus 4 equals minus a half x plus 23 over 2, times everything by 2. 4x plus 8 plus x equals 23. 5x equals 15. Okay, x equals 3. That's not too bad. And y is equal to 2 times 3 plus 4, which is 10. All right, so point B is 310. Distance AB could be found. So we have A and B. A is 5.8, 8.6, and B is 310. The distance between the 2 points can be found square root of y1 minus y2. Why would I do that? x1 minus x2 squared plus y1 minus y2 squared, which is square root, and that's going to be 5.8 minus 3, 5.8 minus 3 squared plus 8.6 minus 10 squared, which is 2.8 squared plus 1.4 squared. The last thing I want to is to find 2.8 squared. It's not nice, but I noticed that 2.8 is 1.4 times 2. So let's do this. It's 1.4 squared times 2 squared plus 1.4 squared. And now I have a common factor, is 1.4 squared, open bracket, 2 squared plus 1. And then I have square root of 1.4 squared times 2 squared plus 1, that's 5. So square root of 1.4 squared times square root of 5, which is 1.4 square root 5. Okay. Did you understand what I did? Rather than calculating, I noticed that 2.8 is 1.4 times 2. So I took 1.4 out. That's what I did. And then I was left with square root 5. Like in a real life scenario, I would do it quicker. I would do 2.8 squared plus 1.4 squared. Or I say that I take 1.4 out, so 1.4. When you take it out, it becomes 1.4 without the square. And then it's here, this is 2 squared plus 1, which was 1.4 times square root 5. So it's much faster than trying to actually calculate it on your calculator. Nice. All right, so that's it. That's the task. It's a tough one. Sorry, it's not a tough question. It's a long question. I've got 2 more longish questions to go, and then some questions from the assignment. Not exactly, but I've made them incredibly similar. Okay, problem 4. The points are 5 minus 2, 5 minus 2, and S90 lie on the straight line L1 as shown. Work out an equation for straight line L1. Okay, so you have 2 points, so straight line, easy. So A, line RS. So y minus y1 equals y divided by 2, y2 minus y1 equals x minus x1 over x2 minus x1. We substitute that in, so y minus y1, which is plus 2, divided by 0 plus 2 equals x minus x1 to x minus 5 divided by 4, or 9 minus 5, which is 4. So y plus 2 over 2 equals x minus 5 over 4. 2 and 4 cancel, and you get y is equal to x over 2 minus 5 over 2 minus 2. Y is equal to x over 2 minus, what's that, 9 over 2. 9 over 2, and that's the equation. Good. So done. B. Work out an equation for the straight line L2. What do we know about L2? L2 passes through this point, and L is perpendicular. Okay, so gradient of L1 is 1/2. That means the gradient of L2 is -2. It's a negative reciprocal. And L2 passes through 5 minus 2. Okay, so we use the y minus y1 equals m x minus x1. Y minus plus 2 equals m, which is -2, x minus 5. So y is equal minus 2x plus 10 minus 2 plus 8. That's the equation of L2. This is L1. C. Write down the coordinates of t. Well, t is the y-intercept of L2. So t has coordinates 0, 8. That's very straightforward. 0, 8. This is because we'll just look at the equation of line L2, and the gradient is minus 2, the y-intercept is 8. So that's it. D. Work out the lengths of RS and TR. RS and TR. Well, RS is the square root of x1 minus x2 squared plus y1 minus y2 squared. That is 5 minus 9 squared plus minus 2 minus 0 squared. Square root 5 minus 9, that's 16, plus 4, that's square root of 20, which is 2 square root of 5. RS, now TR. TR, that's 0, 8, and 5 minus 2. So that's 0 minus 5 squared plus 8 plus 2 squared. And that is 5 squared, that's 25, plus 100. Once again, so here I can take 25 out. So I can take 25 out, it becomes 5 square root, and that's 1 plus 4. Yeah, I hope that makes sense. I take 25 out, it becomes 5, and I'm left with 1 plus 4. So that's 5 root 5. That's TR. And now they're asking, what is the area of triangle RST? RST, so E, triangle RST, T, R, S. We know that this is a perpendicular. This is perpendicular. And this RS is of 2 root 5. And this is 5 root 5. The area of a right angle triangle is 1/2 times the times the product of the two smaller sides, two catheters. I think that's the correct word. But you can also do it like this. So area of a triangle is 1/2 AB sine C. In this case is 1/2 times TR times RS times sine R, which is 1/2 times 5 root 5 times 2 root 5 times sine of 90 degrees. But sine 90 degrees is 1. And that is 1/2. So 5 times 5, which is 25. That's it. The answer is 25. Okay. Problem 5 is very similar to problem 4. Would you like me to do it or move on? Do it or move on. Vote in the chat, please. Move on. Okay. Yeah, happy. is similar to problem 4. Because the next question you can recognize. I've changed the values, so it's not the same. So I've changed the coordinates of the points. I've changed the ratios, but hopefully you'll get an idea of how to do this problem. This is problem 6 from the assignment. We have 4 points. It's a square. The line CN intersects the lines OM and OB at points P and Q. Find the ratio of OP to PQ. Well, all we need is to find the is to just a second. CM to MB is 1, 2, 3. BN, yeah, okay. So all we need to find is the OP to PQ. OP to PQ. Okay. OP to PQ is question mark. That's what we need. There are different ways you can do this. First of all, you could potentially find OP, find PQ, and then find the ratio. Of course, that's the straightforward way. You just need to find method 1. Find coordinates of P and Q. And then find the length OP, find the length PQ. Easy. Well, easy-ish if you know how to find the coordinates. So we know that point M, we know the coordinates of point M because the ratio is 1 to 3. That means it is a quarter. So M is 0.5, 2. So M is 0.52. N is 2, 1.5, because that's the ratio, 1 to 3. And then find line. Oh, it's given. That's given. Right, and M and N. In your problem, it's the ratio is 1 to 1, so it's different. So you have these coordinates. So you have the line OM. You can find the equation of line OM. Line OM, and that is you can use it goes through 0, 0. So all you need is to find the gradient, because it's y equals mx plus c, which is 0. All right, so you need to find the gradient. M is 2 minus 0 over 0.5 minus 0, which is 4. So line OM has gradient 4. So equation of the line is y equals y minus 0 equals 4, x minus 0. So y equals 4x. That's the equation of line OM. Line OM is OM. Now we find line OB. line OB, and that's the easiest line because it's just y equals x. Now we need to find the line CN. Line CN. And you can use the 2 points equation, y minus y1. Why would M? The point M, because it's not the midpoint. It says the CM to MB is 1 to 3, so it's a quarter. It's a quarter of the 2. So there's a question, why would M be not 1? Yeah, it's not midpoint. Y minus y2, y2 minus y1 equals x minus x1 over x2 minus x1. And from here, y minus, so Cn. N is 2, 1.5. Y minus 1.5 over 2 minus 1.5 equals x minus x minus 2 and then 0 minus 2. Okay. So from here, 0.5 divided by 0.5 equals x minus 2 divided by minus 2. So y equals 0.5, so minus a quarter x minus a quarter times 2, so plus plus a half, so plus and plus 3 over 2. So y equals minus a quarter x plus 2, and that makes sense. So that's line CN. Okay, so now we need to find the points P and Q. So P and Q is the intersection. So P is intersection of line OM and line CN. Okay. Yes, I'm using the intersection symbol, and that is C. So y equals OM, that's 4x, and y equals minus a quarter x plus 2. Sub that in, 4x equals minus a quarter x plus 2 times everything by 4, 16x equals minus x plus 8, 17x equals 8, x equals 8 over 17. We can find y. Y is 4x, so that's 32. 32 over 17. Okay. And then Q is the intersection of y equals x and y equals minus a quarter x plus 2. And that means we have x equals minus a quarter x plus 2. 4x equals minus x plus 8. 5x equals 8, x equals 8 over 5, y is equal to 4 times this, so that's 32 over 5. Okay. So distance So finally, distance PQ, that's going to be square root of 8/17 minus 8/5 squared plus 32/17 minus 32/5 squared. Doesn't look pretty. Hopefully we can do something about it. So 8 squared, we can take 8 squared out. 8 squared, 1/17 minus 1/5 plus 32 squared, 1/17 minus 1/5, which is 1/17 minus 1/5, so that's squared, of course, squared. So 1/17, that's 17 minus 5, that's 12. So 8 squared times 12 squared over 17 squared times 5 squared. I realize you don't have to do this. Plus 32 squared times 12 squared, 17 squared times 5 squared. This is what I do when I don't have a calculator. Well, I do have a calculator, but 17 times 5 square root 8 squared plus 32. Ooh, they all both have 8 squared, so I can take 8 out. And that would be 1 plus 4 squared, which is root 17. Nice. So it's 12 times 8 divided by 17 times 5, root 17. Okay, and that's the distance PQ. And now we need to find the distance OP. OP. Apologies, if you just wait for a second to just pop out. I'm back. Sorry. Right, so the distance OP is distance OP is square root P. So we know that P is 8/17. So 8/17 squared plus 32/17 squared. Take 17 out. 17. 8/17 we can take out, and it's going to be 1 plus 4 squared. which is 8 root 17 over 17. Okay, and finally, the ratio that we need is, which one do we need? OP to PQ. OP is 8 root 17 over 17 divided by 12, 8 root 7 times 8 root 17 over 17 times 5. Root 17 cancels, 8 cancels, 17 cancels, and we get 5 over 12. And that's the answer. So I've made it harder than it is in the assignment. That's one way of doing it. The second way of doing it, I think I just invented it. I think I can do it. I'm not 100% sure in this method, but let's see. PQ divided by PO, that's the opposite of this ratio. That's the inverse of this ratio. If you look at it, because this is 90 degrees. Why is this 90 degrees? Because line CN has slope minus 1/4, and line OM has gradient of 4, so they're perpendicular. So PQ over OP is the tangent of this angle theta. Tangent theta. Okay. Gradient of OB is equal to 1. That means that the tangent of this angle, let's call it alpha, tangent alpha is 1. That means the alpha is 45 degrees. So this is 45 degrees. And now OM, gradient of OM is 4. That means that tangent beta, let's call this angle beta, like the big one, beta. Tangent beta is 4. That means the angle beta is arced the inverse tan of 4. So the angle theta, tangent of the angle theta, which is this, is the tangent of beta minus alpha. And there's a formula for tangent beta minus alpha, which I don't remember. Tan A minus B. Tan minus tan. Yeah. So that's tan beta minus tan alpha divided by 1 plus tan alpha times tan beta, which is tan B, which is 4, minus tan alpha, which is 1. All right, 1 plus tan alpha, which is 1 times 4, which is 3 over 5. Okay, tan theta. So that's PQ. PQ over PO is 3 over 5. And that means that PO over PQ is 5 over 3. Not exactly. That's exactly what we got. But I tend to think that we've made a mistake here. Of course we have. Oh, 5/12. No. I might have made a mistake here. I think so. I'm off by a factor of 4, as you can see. So, method 2. Method 2, using trigonometry. Gradient is -1/4. This is 4. So that means that they're perpendicular. So the gradient is PQ over PO. That's this angle. This is 4. This is 1. I definitely haven't made a mistake here. In Q, yes, thank you. Yes, yeah. Thank you, well spotted. So this is not 32 over 5. X is 8 over 5, and Y is 8 over 5. Y is 8 over 5. Apologies. So that would be PQ. That's 32 over 17 minus 8 over 5. Distance OP. Okay, so I need to recalculate that. Okay, so that is 8 squared, and that is 32, which is 8 over 5, 8 squared. Ooh. That's 4 squared minus over 17 minus, sorry, 4 over 17 minus 1 over 5. Okay, so that's 8 squared, square root 117, so that's 12 squared over 17 squared times 5 squared plus 8 squared, so that's 20 minus 17, that's 3 squared over 17 squared times 5 squared, which is 8. 17 times 7 times 3, open bracket, 4 squared plus 1, which is 8 times 3 square root 17 over 17 times 7. And this is 3. Okay, so it's 5 over 3. All right, got it. Thank you. Nice. Which method did you like more, method 1 or method 2? Method 2. Okay. Yeah, it's very nice because if you realize that you have a line and you know the angle, you have another line and you have another line. So this angle theta, this angle is beta, this angle is alpha. So theta is beta minus alpha. And the ratio that you want is tan theta. And tan theta can be found as tan beta minus tan alpha divided by 1 plus tan alpha, tan beta. That's a formula you can look up. So yeah, go ahead. You can do this problem in a similar way. Problem 7 is the same as problem 10. Find the area of the triangles formed by the line and two lines drawn from the origin at 45 and 60 degree angles to the x-axis. So you have a line drawn at 45 degrees. Okay, so that's easy. 45 degrees, that is y equals x. 60 degree to the axis, that's this one. And it has the y-intercept is 0, so and the gradient is tan 60. And tan 60 is square root of 3. So y equals square root of 3x. That's the equation of the line. 2x plus y equals 10 is a straight line that goes through 5 and 10. Okay. So you want to find the area of this triangle. Well, there are several ways you can do this. Okay. You can use the formula 1/2 base, 1/2 a base times height. The question is, what would the base be? Well, I would say this is the base, this side. And the height is the distance from this point to this straight line. So that's the height. So you can do it like that. All right, so let's give it a go. So we need to find this point first. So let's call it P, Q. And we will need another point which is perpendicular. Let's call it point M. Okay. OM. OM is perpendicular to the line, so that's the height. Height is OM. Maybe not the best drawing, but you have a triangle like this, and the height of this triangle is that. Okay. Right. So to find point Q, that's the intersection of two lines. Point P is the intersection of two lines. All right. To find point P, we need 2x plus y equals 10 and y equals x. So that's 3x x equals 10, x equals 10 thirds, y equals 10 thirds. That's point P. To find point Q, you need to find y equals square root 3x and 2x plus y equals 10. Okay, not as easy. 2x plus root 3x equals 10. X equals 10 over 2 plus root 3. Okay, y is root 3x, so it's 10 root 3 over 2 plus root 3. I wouldn't. Okay, so that's q, and then you can find the distance PQ, obviously. That's not hard, and I'll leave it to you to find this distance, but obviously it's a different question. It's a slightly different question. So PQ is the base. PQ is square root of something of that. Now, if you want to find OM, find the equation. Find equation of OM first. Well, because the gradient of QP, that's that line. QP is minus 2. Is minus 2. So the gradient of OM is perpendicular, so it has to be 1/2. So line OM has equation y equals 1/2 x. So this line is y equals 1/2 x. And therefore, you can find point M. M is the intersection of 2x plus y equals 10 and y equals 1/2 x. So 2.5, 2.5 x equals 10, x equals 4, y equals 2. Okay, so we have point M, which is 4, 2. We have point P, which is 10 thirds, 10 thirds. And we have point Q, which is just plain awkward, but it's there. So all you need to do is find OM. OM is square root of 2 squared plus 4 squared, which is 4 plus 16, square root of 20. That's 2 root 5. OM is 2 root 5. The base we have found previously, and the area of the triangle is 1/2 times the base times OM. I won't finish this question, but I really hope you got it. Now let's move on to circles. The circle C has equation. Lines L1 and L2 are the tangents to the circle. Well, any circle has equation x minus x0 squared plus y minus y0 squared equals r squared, where x0, y0 is the center and r is the radius. So if you take this equation, x squared plus 6x plus y squared minus 2y equals 7, you can complete the square. You can complete the square here, and you can complete the square here. This is going to be x squared plus 6x. So completing the square. X plus, we're missing 9 here to complete the square, plus y squared minus 2y plus 1. And then we do minus 9 minus 1 equals 7. So that's x plus 3 squared plus y minus 1 squared. That's 10, 10 plus 7, 17. So this is the equation of the circle. So the center of the circle is minus 3, 1. And the radius is square root 17. Find the equations of the lines L1 and L2. L1 and L2. Okay. What do we know about line L1? So, to find line L1, what do we know? We know that it passes through the point R. That means we can write down the equation y minus y1 equals m x minus x1. But that means that y minus 6 is equal to m multiplied by x minus 0. That means y is mx plus 6. So this is the line L1 where m is unknown. We have the circle x minus 3 plus y minus 1 squared equals 17. That's the circle. We know that line L1 is tangent to the circle. Well, it is perpendicular to the radius, but you don't know the radius. The radius is AQ, and you don't know where Q is. So that's a problem here. L1 is tangent to the circle. That means it has only one point of intersection. That means that the simultaneous equation has one solution. So x minus 3 squared, so sub y equals mx plus 6. X plus mx plus 6 minus 1 squared equals 17. Open the brackets. Well, actually, you know what? We didn't have to do this. X squared minus 6x plus 9 plus, this is 5. So m squared x squared plus 10mx plus 25 equals 17. This is a quadratic equation. So x squared m1 plus m squared plus x 10m minus 6 plus 9 plus 25, that's 34. 34 minus 17 is 17 equals 0. This quadratic equation has one solution, right? Only one point of intersection. That means that the discriminant is 0. So the discriminant, which is b squared minus 4ac, must equal to 0. That means 10m minus 6 squared minus 4 times 1 plus m squared times 17 must equal to 0 AC. That is 100 m squared minus 120 m plus 36 minus 4 times 17, that's 78. 4 times 15, 60, 68. Yes, 68. 68 minus 68 m squared must equal to 0. 100 minus 68 is 32 m squared minus 120 m minus 32 must equal to 0. Can we actually divide it by something? By 8? So it's 4m squared minus 15m minus 4 equals 0. Okay, and 3, 4 minus 15 minus 4, which is 4 and minus a quarter. So m is 4, or m is minus a quarter. And you can see those are the lines. So here the line m equals 4 and m equals minus a quarter, which doesn't look like it. Have I made a mistake somewhere? Minus a quarter. 0.6. Y equals mx plus 6. That is correct. And oh yes, plus. No, that's minus 1. This is plus 1. So this is plus, and this is plus. So that is plus. That is plus. This is plus. This is plus. And this is minus 4 and plus 1 quarter. All right. Not that bad. So m equals 1 quarter and m equals minus 4. All right. And now we can find P and Q. All right. So line L1 has equation y equals minus 4x plus 6. And this line has equation y equals 1 quarter x plus 6. And then you can find the intersections P and Q. And then it says find the area of the quadrilateral APRQ. APRQ. Okay, so let's find P. Find P. To find point P. when we solve simultaneously, y equals 1/4 x plus 6 and x plus 3. You know what? I don't need this equation. I can use the original one. X squared plus 6x plus y squared minus 2y equals 7. I sub that in. X squared plus 6x plus 1/4 x plus 6 squared minus 2 times 1/4 x plus 6 equals 7. X squared plus 6x plus 1/16 x plus... Okay, that's going to take a while. But the point is we can find point P. And let me show you how well, I mean, okay, let me try to finish this. 1/4 x plus 12x over 4 plus 36 minus half x minus 3 equals 7. X squared, 12, that's 3. 16th minus half plus 3x plus 9x. 9x minus just 8 16 minus 7 16th x plus 36 minus 10 equals 0. I'm just going to use the, wouldn't it be 1/16 x squared? Yes, it would be. Thank you. 50 17 16th x squared 6 9 minus a half plus 17 over 2x plus 26. Have we established that correctly? 26 minus 10, yeah, 26 equals 0. Multiply everything by 16, so 17x squared plus 34x plus 16. 16 times 26, 416 equals 0. Okay, I'll ask my calculator to solve this. 17, 34, 416. No solutions. Must have made a mistake somewhere. Is it not 136? 16. I think you're right, 16 times. 17 times 8. 136, yes. 136. And then equation 3, 17, 136, 416. Still no solutions. Should have one solution, but it doesn't. Not sure. I made a mistake somewhere. Sorry. It's not really important. The important thing is that you find point P, you find point Q, and then you have two right angle triangles. and okay, you have two right angle triangles. This is root 17. This is root 17. You know the coordinates of P, you know the coordinates of Q. This is a right angle triangle, so all you need is to find this distance, RP. So the area is going to be AQ multiplied by QR. Of course, it's 1/2, but there's two of them, so it's just that. Okay, so I hope it was helpful today. I won't do problem 9. I'll stop here. I hope it was helpful. Please watch my last year's webinar. It's completely different. If you still need help, if you're still not certain, but otherwise, I'll see you. When do I see you? Let's check. Webinars. The next webinar is on the 16th of December. Right. See you all.